Hey everybody, in this video I'm going to show you how to study for general chemistry using a repeatable setup method, and then we're going to do 8 core problems step by step with full work, units, and answers. The goal isn't speed, the goal is correct setup. It's your soft-spoken scientist. Let's get started, alright? So the setup method is you're going to write what is given in units, what the question is giving you, what values they're giving you with units. You're going to write down the goal. What's the question asking for? Are they asking for moles? Are they asking for mass? What are they asking for? That's the goal. You're going to choose a conversion or a formula to apply. You're going to cancel the units as you see them. Usually, a numerator on one and a denominator. That's how it's usually done. That's how you cancel out the units. You're going to do computing. So you're going to use your TI-83 plus calculator. And then you're going to use units and magnitude at the end to check. If you do these 6 steps every time, general chemistry becomes predictable. Okay, let's look at this problem. Convert 3.75 kilograms to grams. All right, so what is the given? Oh, the given is 3.75 kilograms. The goal is to get grams. And the conversion, I'm going to show you another way of doing this, but the conversion is 1 kilogram equals 1,000 grams. So I have 3.75 kilograms, and I'm trying to get to grams. That means that I need to get rid of kilograms as a unit. That means kilograms has to be in the denominator to cancel out. Because if it's in the numerator, if we had kilograms, oh, good golly. If I had kilograms in the numerator, kilograms would be something, it wouldn't be canceled out, it would become greater, okay? When they're on opposite, one's in the numerator, one's in the denominator of 2 different fractions, because technically it's over 1. The kilograms will cancel out, okay? So I have 1 kilogram is equal to 1,000 grams. 3.75, there's a bunch of zeros after that. They're just not written and they're invisible. Times 1,000. That just means we move the decimal point 3 times to the right, because we have 3 zeros. 1, 2, 3. So 3,750 grams. This is your answer. Now, let's look at this one. Maybe you'll use it, maybe not. It's just something I learned. King Henry died by drinking chocolate milk, okay? This represents kilograms. This is base, and base represents grams. Okay? So 1, 2, 3. To go from kilograms to grams took 3. So if I'm at 3.75, and I'm adding by 3, 1, 2, 3. Just move the decimal point 3 places forward. 1, 2, 3. 3,750 grams. But I wanted y'all to show your units, and I wanted you guys to do the given goal conversion. So this is a good way to do it. This is a good way to check your work, and I'll do a whole video about this a little bit later. Okay, let's talk about problem 2. So it says convert 125 milliliters to liters. So the conversion is that 1 liter is equal to 1,000 milliliters, right? So I have 125 milliliters. What would be in the denominator? If I want to get rid of milliliters and go to liters, milliliters would be in the denominator. So I have 1,000 milliliters is equal to 1 liter. I'm going to divide the milliliters out, they cancel out, and I have 125 divided by 1,000. So there's a bunch of zeros, so the decimal point's right here, and I have 125. And there's a bunch of zeros behind the 1, just no one ever talks about it, which is why you might struggle a little bit. So you're going to move to you're dividing by 1,000, you guys. You're not multiplying. If you were multiplying, you would move to the right. So this is multiplication world, and then when you're dividing by 1,000, you're going to the left. So I'm going to move to the decimal places by how many times? I have 3 zeros. So 1, 2, 3. I have 0.125 liters. That's how you do that, okay? The other way you could do it, as a way to check your work, you could do, again, King Henry died by drinking the chocolate milk, right? So this M represents milliliters. This is a base, as we talked about. The B represents base, and that would be grams, that would be liters, right? So if I'm at 125 milliliters, look at this. 1, 2, there you go, 3. So it still tells me the same thing. I got to move back 3 times. 1, 2, 3, 0.125 liters. Milliliters to liters should get smaller. There you go. Okay, let's talk about this one. They said in the form problem, mass is 84 grams, volume is 12 milliliters, find the density. Here's the density formula you guys need to know. Density is mass over volume. So density is 84 grams divided by 12 milliliters. That would get me 7. Okay. Now, I'll do another video about this, but I have 2 digits that are included. So it's 2 sig figs. So it would be 7.0. So I have 1 digit, 2 digit. Okay. I'm not going to just write it as 7. Some teachers are really on it about the sig figs. Some are not, but yeah. So it'd be grams over milliliters. And guess what? That is the unit for density. Okay, there you go. Let's try this one. Convert 25.0 degrees Celsius to Kelvin. The K is for Kelvin, you guys. So here is the formula, and you guys are going to do this when you go to college or high school. You do it in either one. One or the other. Okay, Kelvin is degrees Celsius plus 273.15. So I'm going to say, well, K is equal to 25.0 plus 273.15. And then when I do the math, I'm going to get 298.15 Kelvin. And remember, Kelvin should be greater than Celsius. And guess what? It is. Okay, how many moles are in 18 grams of water? Molar mass is 18.0 grams per mole. Okay, so on an exam, they may not tell you the molar mass of water. You're going to need to just know that you may have a periodic table on the exam. And just so you know, the atomic mass of oxygen is 16, and then hydrogen is like 1, and then another hydrogen would be 1, and 16 plus 1 is 18. Okay. So, how many moles are in that? 18 grams of hydrogen, and the molar mass is that. Okay. So, we're given that we have 18 grams of H2O. Our goal is to get into moles. It says how many moles? Well, we got to find that out. And then I know that the conversion is 1 mole of hydrogen, 2 hydrogens and an oxygen, also known as water, is equal to 18 grams of H2O. So I'm going to take this 18 grams of H2O, and I'm going to, well, let me include the 0.0, you know, for significant figure reasons. 18.0 grams of H2O. It's going to be multiplied for 18 grams for every 1 mole of hydrogen of H2O. Right? It's come from that. It's from H2O, but I just write the grams. The grams will cancel out, and then I'm left in moles, which is what I wanted. What's 18 times 1? 18. What's 18 divided by 18? 1. So the answer is 1 mole. All right? Let's try this one. How many molecules are in 0.250 moles of CO2? And they told me the 6.022 times 10 to the 23rd is molecules for all the moles. So it's 0.250 moles. And I know that for every 1 mole, there are 6.022 times 10 to the 23rd molecules. All right? And when I plug that in my calculator, because I'm not a genius, I'm going to get 1.5055 times 10 to the 23rd molecules. All right? And I know I did this right because I can cross off my moles. And by doing that, I see, to myself, okay, there's 3 significant figures after the 0, 2, 5, 0. Again, so that's 3 significant figures, so I need to make this 3 significant figures. So 1.51. Because guess what? 1 sig fig, 2 sig fig. So this would be the 3/3 sig fig. But it would be rounded up because the one after the digit after 0 is a 5. And if it's a 5 or above, you give it a shove. So you have 1.51 times 10 to the 23rd molecules of CO2. Let's try this one. A compound is 40.0% carbon, 6.70% hydrogen, 53.3% O. Find the empirical formula. So the step 1 is to assume it is a total, from what we're seeing, of 100 grams. We know we have, for carbon, we have 40.0 grams. H, you're going to turn that into grams, 6.70 grams. O, 53.3 grams. Okay. Now, we're going to convert to moles. Use approximate molar masses. So C, just so you all know, and you'll see on your periodic table, C is 12.01, H is 1.008, O is 16.00. All right? So I'm going to do I'm going to write out the moles of carbon equals 40.0 divided by 12.01. That would get me 3.33. The moles of hydrogen equals 6.70 divided by its atomic mass 1.008. And I got 6.65. The moles of oxygen is 53.3 grams divided by the 16.00. And I also got 3.33. So, in the empirical formula, is what we need to find. Empirical formula. So just keep that in mind as we're doing this. Okay. So, step 3. When you got all of the moles here, all right, you need to divide by the smallest. And the smallest is 3.33. Whether you're talking about the mole of O or the mole of C, it doesn't matter. We all acknowledge that 3.33 is the smallest. So I'm going to divide all of them by 3.33. 3.33 divided by 3.33 is 1. 6.65 divided by 3.33 is 2. Add your sig figs. 3.33 divided by 3.33 is 1.00. All right. So I see that it looks like carbohydrate building block, right? Ratios, clean, it's great. I'm seeing that going on. So I have 1C. This is saying, hey, you got 1C. This is saying, hey, you got 2 hydrogens. Boom. Hey, you got 1O. That's my empirical formula. All right. Now, we're going to do a limiting reagent. This is intro level. It's very common, okay? So if this is the reaction, and if you have 5 moles of hydrogen, right? And 2 moles of oxygen, which is limiting. So what's they're telling, which is limiting, and how many moles of water form? So these are really great questions. Okay, So step 1, compare using stoichiometry. You know the needed ratio is 2 moles of hydrogen per every mole of oxygen. So, and we know that because of the equation. So if O2 is 2 moles, the H2 needed is 2 times 2.0, right? Which would get me 4 moles of hydrogen. We have 5 moles of hydrogen, H2. So guess what? H2 is excess. So O2 would be limiting. Okay? From the equation, we see that we have 1 mole of O2 and 2 moles of water. So we're going to take 2 moles of O2 and we're trying to get to water because that's what's formed in the product. So I'm trying to canceling out my moles of O2. And for every 1 mole of O2, guess what, you guys? I have 2 moles of hydrogen. Because remember, there's an invisible 1 right here. And then I have a 2 right here. So 2 moles of H2. Oh. Which got me 4 moles of hydrogen, H2O. So, the answer is this. The limiting is O2. And guess what? The water produced is 4.00 moles of water. All right. If you want to get better at Gen Chem, your job is to practice setups like this until they feel automatic. Given, goal, conversion, cancel units, compute, check. If this video helped you, please like and subscribe, please. And remember, STEM is for everybody, especially you. Thanks, guys.